You can add, subtract, multiply, and divide functions similar to how you perform these operations with real numbers. However, you must at times consider the domain, the x value, of each function. If you're adding functions, if you have f plus g of x, that's the same thing as f of x plus g of x. If you're subtracting functions, f minus g of x would be the same as f of x minus g of x. Multiplying functions, f times g of x, that is the same as f of x times g of x. And finally, dividing functions, f over g of x would be the same as f of x divided by g of x, or f of x over g of x. The domain of the quotient function does not contain any value for which g of x would be equal to 0. So you cannot have the denominator equal to 0. If the denominator is 0, that means you're dividing by 0, and that is undefined. Let f of x equal 4x plus 7 and g of x equal the square root of x plus x. What are f plus g of x and f minus g of x, and what are their domains? So for f plus g of x, that's the same thing as f of x plus g of x. So take what f of x is, 4x plus 7, add that on to what g of x is, the square root of x plus x. So you have 4x plus 7 plus the square root of x plus x. Go back through and combine any like terms. Like terms would be 4x and x. If you combine those, that is 5x plus the square root of x plus 7. So when you add f of x plus g of x, that is 5x plus the square root of x plus 7. Now when you're stating the domains, you want to look for any restrictions. Restrictions would occur with a square root sign or a fraction. For a square root sign, what's under the square root sign? It can't be negative because that would be imaginary. And with a fraction in the denominator, that can't be 0. Because if you have a denominator that is 0, you're dividing by 0, and that is undefined. So for the domain of f, if you look at f of x, that's 4x plus 7. There are no fractions, there are no square root signs, so there are no restrictions. In other words, the domain of f, the x values in f of x, would be the set of all real numbers. For the domain of g, if you look at g of x, you have a square root sign. It's the square root of x plus x. So what's under the square root sign cannot be negative. So the domain of g would be the set of all real numbers where x must be greater than or equal to 0. Because if x was less than 0, that would be a negative under that square root sign, and that would be imaginary. And for the domain of f plus g, that is this 5x plus the square root of x plus 7. Again, you have a square root sign. What's under the square root sign can't be negative, so x must be greater than or equal to 0. So the domain of f plus g, or f of x plus g of x, would be the set of all real numbers where x is greater than or equal to 0. Now for f minus g of x, take what f of x is, subtract g of x. So 4x plus 7 minus the square root of x plus x. So that is the same as f of x minus g of x, 4x plus 7 minus the square root of x plus x. Distribute that negative sign through that set of parentheses. It'd be the negative of the square root of x minus x. So 4x plus 7 minus the square root of x minus x. Go back through and combine any like terms. Like terms would be 4x and negative x. If you combine those, that is 3x. So it would be 3x minus the square root of x plus 7. Now the domain of f, just as it was above, if you look at f of x, there are no restrictions. There are no square root signs, no fractions. So the domain of f would be the set of all real numbers. The domain of g, again, as it was before, g of x equals the square root of x plus x. You have that square root sign. What's under the square root sign cannot be negative. So the domain of g would be the set of all real numbers where x must be greater than or equal to 0. And for the domain of f minus g, this f of x minus g of x, or 3x minus the square root of x plus 7. With that square root sign, that's a restriction. X must be greater than or equal to 0. So the domain of f minus g, or the x values, would be the set of all real numbers where x must be greater than or equal to 0. The domain of both f plus g and f minus g is the set of numbers common to both f and g. Let f of x equal x squared minus 9 and g of x equal x plus 3. What are f times g of x and f over g of x? And what are their domains? Starting with f times g of x. So that is f of x times g of x. Take what f of x is, x squared minus 9, and multiply that by what g of x is, x plus 3. So be x squared minus 9 times x plus 3. Use the FOIL method or distributed property there. That'd be x to the third plus 3x squared minus 9x minus 27. The domain of f times g. So look for any square root signs, any fractions, which there are none, so there are no restrictions. That means the set of x values would be all real numbers. There are no restrictions on the domain. It's a set of all real numbers. For f over g of x, take what f of x is, divide that by what g of x is. So f of x is x squared minus 9, divide that by x plus 3. So it'll be x squared minus 9 over x plus 3. Now that x squared minus 9, that will factor into two binomials. That is a difference of two squares. So that will factor into x plus 3 times x minus 3. Now you want to factor that so that you can cancel with what's in the denominator. You want this to be completely simplified. So x plus 3 and x plus 3, those cancel. And if you cancel those, you are left with x minus 3. Now it says where x is not equal to negative 3. Because if you go back through this, if x was negative 3, the denominator would be 0. And you don't want a denominator 0 because that is undefined. So the domain of f over g, or the x values of f of x divided by g of x, would be the set of all real numbers except x cannot be equal to negative 3. Because again, if x was negative 3, those denominators would be 0, and that is undefined. In a composite function, the output of the first function becomes the input into the second function. For example, if you have f of x equals x minus 5 and g of x equals x squared, you need to find g of f of negative 3. Now we're going to do that example in a little bit. But when you think about a function, you want to think about a machine. When you put something into a machine, there's an output. Now with these composite functions, that output then becomes the input into that second machine, or that second function. So if you put something into f of x, for example, we're putting negative 3 into f of x, so we're finding f of negative 3. There's an output that will be created. That output then becomes the input into g of x. And then when you put something into g of x, there's going to be an output. And that final output is that g of f of x, or in this case, it's going to be that g of f of negative 3, which we'll see in a little bit. And here we go. F of x equals x minus 5 and g of x equals x squared. Need to find g of f of negative 3. So that negative 3 is going to be the input into f of x. Then there's going to be an output, and that output will go into g of x. So find f of negative 3 first. You're going to take that x in f of x and replace it with negative 3. So we're inputting negative 3 into f of x. So finding f of negative 3, replace the x in f of x with that negative 3. So it'd be negative 3 minus 5, and that is negative 8. So that is the output. When you put negative 3 into f of x, the output is negative 8. And that output becomes the new input going into g of x. So we'd be finding g of negative 8, or g of f of negative 3. So f of negative 3 was negative 8. We're replacing that x in g of x with that negative 8. So it'd be negative 8 squared, and that is 64. That is the final output. That is g of f of negative 3, 64. Let f of x equal x minus 5 and g of x equal x squared. This time, we're finding f of g of negative 3. So we're going to input negative 3 into g of x first. We're finding g of negative 3 first. We're going to get an output, and that output will be the input going into f of x. So find g of negative 3 first. Replace the x in g of x with that negative 3. It'd be negative 3 squared, which is 9. That 9, the output, when you put negative 3 in for x into g of x, the output is 9. That's going to be the input going into f of x. So we'd be finding f of 9, or in this case, f of g of negative 3. That g of negative 3 was 9. So replace the x in f of x with that 9. It'd be 9 minus 5, and that is the final output, 4. So when you find f of g of negative 3, when you put negative 3 into g of x, get an output. The output is 9. Put that output into f of x, you're going to get a final output of 4. F of g of negative 3 is 4. Let g of x equal 2x and h of x equal x squared plus 4. Find each value or expression. We're going to find h of g of 1. So we're going to input 1 into g of x, find g of 1 first, then that's going to create an output. That output then goes into h of x. So to find g of 1, go to what g of x is, that's 2x, and substitute 1 in for x. So replace the x in g of x with 1. You're finding g of 1, that is 2 times 1, which would be 2. So that output of 2 then becomes the input into h of x. So go to what h of x is, x squared plus 4, and put 2 in for x. You're inputting 2 in for x into h of x. So you're finding h of 2, or you might think of that as h of g of 1. So h of 2 would be 2 squared plus 4. That is 4 plus 4, and that is 8. So the final output is 8. So when you find h of g of 1, that is 8. For g of h of 0, going to find h of 0 first. That'll create an output. Then that output becomes the input into g of x. So find h of 0. Go to what h of x is, x squared plus 4, and replace that x with 0. So it'd be 0 squared plus 4. That is going to be 0 plus 4, and that is 4. So that output becomes the new input into g of x. So go to what g of x is, that's 2x, and replace that x with that 4. So you're putting that 4 in for x into g of x. So finding g of 4, or you might think of that as g of h of 0. So g of 4, that'd be 2 times 4, which is 8. That is the final output. That is g of h of 0. It is 8. If you have g of h of a, so we have an a there instead of a number, no big deal. Find h of a first. So go to what h of x is, that's x squared plus 4. Replace that x with an a. So that would be a squared plus 4. Now that output, a squared plus 4, becomes the new input into g of x. So go to what g of x is, that's 2x, and replace that x with that a squared plus 4. So you're finding g of a squared plus 4, or in other words, g of h of a. Just replace that x with that output back here of a squared plus 4. So it'd be 2 times a squared plus 4. Distributive property, that is 2a squared plus 8. That is the final output. That is g of h of a. Let g of x equal 2x and h of x equal x squared plus 4. Find each value or expression. So we're going to find h of g of negative 5. So find g of negative 5 first. Go to what g of x is and replace that x with that negative 5. So you're inputting negative 5 into g of x. So finding g of negative 5, that would be 2 times negative 5, which is negative 10. That is the output. That output then becomes the input into h of x. So go to what h of x is, x squared plus 4. Put that negative 10 in for x. So finding h of negative 10, or you might think of that as h of g of negative 5. H of negative 10, that would be negative 10 squared plus 4. If you square negative 10, that is 100. It's 100 plus 4, and that is 104. That is the final output, 104. That is h of g of negative 5. We're going to find h of a. So find h of a first, then that output will become the input into h of x again. So to find h of a, go to what h of x is, x squared plus 4, replace that x with an a. So that will just be a squared plus 4. Then that output becomes the new input into h of x once again. So take h of x, which is x squared plus 4, put that a squared plus 4 in for x. So you're replacing that x with that a squared plus 4. Now keep in mind, it was x squared, so that's a squared plus 4 squared. When you square a binomial, when you square anything, you have to multiply it by itself. So we'd be multiplying a squared plus 4 by a squared plus 4. So when you multiply that by itself, you have to use the FOIL method or distributive property. If you do that, it's going to be a to the 4th plus 8a squared plus 16. Don't forget, you still have that plus 4 on the end. Go back through and combine any like terms. The like terms would be 16 and 4. If you combine those, that is going to be 20. So it's a to the 4th plus 8a squared plus 20. That is the final output. That is h of a. A to the 4th plus 8a squared plus 20. Let g of x equal 3x plus 2 and f of x equal x minus 2 over 3. Need to find each value. We're going to find f of g of 1. So we need to find g of 1 first. We're going to put 1 into g of x. So replace the x in g of x with that 1. So it'd be 3 times 1 plus 2. It's going to be 3 plus 2, and that simplifies to be 5. Now that's the output, so you're not done there. You still need to input that 5 into f of x, because we need to find f of g of 1. G of 1 is that 5. Now we need to find f of that. So to find f of 5, replace the x in f of x with that 5. So it'd be 5 minus 2 over 3. It's going to be 3 over 3, and that simplifies to be 1. So the final output is 1. That is f of g of 1? The answer is 1. To find g of f of negative 4. Find f of negative 4 first, so go to what f of x is and replace the x with that negative 4. So it's going to be negative 4 minus 2 over 3. Well, negative 4 minus 2 in the numerator, that is negative 6. That's negative 6 over 3, and that simplifies to be negative 2. Now you're not done there. Again, that's just the output. When you put negative 4 into f of x, that's the output. That needs to be the input into g of x. So we need to find g of negative 2. So to go to what g of x is, it's 3x plus 2, and replace the x in g of x with that negative 2. So you're inputting negative 2 into g of x. So it'd be 3 times negative 2 plus 2. That is negative 6 plus 2, and that is negative 4. So the final output there is negative 4. So g of f of negative 4 is negative 4. Let f of x equal negative 2x plus 5 and g of x equal x to the third. What is g minus f of x? Well, remember, g minus f of x, that's the same thing as g of x minus f of x. So take what g of x is, that's x to the third, and subtract what f of x is, negative 2x plus 5. So it'd be x to the third minus a negative 2x plus 5. Distribute that negative sign through that set of parentheses. Take the negative of a negative 2x, that's a positive 2x, and the negative of 5, that is negative 5. So that would be x to the third plus 2x minus 5, and that is letter B. Let f of x equal 3x and g of x equal x squared plus 1. What is f times g of x? So remember, f times g of x, it's the same thing as f of x times g of x. So take what f of x is, it's 3x, and multiply by what g of x is, x squared plus 1. Should be taking 3x times x squared plus 1. Just use the distributive property there. Take 3x times x squared, it'd be 3x to the third, and 3x times 1, that is 3x. So that is 3x to the third plus 3x, and that is letter H. Let f of x equal x squared minus 2x minus 15 and g of x equal x plus 3. What is the domain of f over g of x? So f over g of x, that's the same thing as f of x over g of x. So take what f of x is, x squared minus 2x minus 15, and put that over what g of x is, x plus 3. Now we're just looking at the domain. So when you think about the domain, you want to think about what x cannot be equal to. X cannot be a value that makes the denominator equal to 0. So a value of x that would make the denominator equal to 0 would be negative 3. So x cannot be equal to negative 3. Or in this case, letter C. Let f of x equal the square root of x plus 1 and g of x equal 2x plus 1. What is g of f of x? So take what f of x is, that's that square root of x plus 1, and input that into g of x. Replace the x in g of x with that square root of x plus 1. So you're taking 2 times the square root of x plus 1. Use the distributive property. 2 times the square root of x would be 2 times the square root of x. And 2 times 1 is 2. Don't forget, still have that 1 on the end. Combine the like terms, 2 and 1, and that is 3. So that would be 2 times the square root of x plus 3, and that is letter F.